2023, Paper 1. Question 1. Which row shows a base quantity with its correct SI unit? Weight is not a base quantity, but we can derive weight to be W equals to mg. Weight is in newtons. Mass is in kg. G is meter per second per second. For temperature, it is in kelvins. Current is not V, it's in ampere. Time is in seconds. Question 2. Which statement is correct? Speed has direction and no magnitude. That's wrong. Speed has magnitude but no direction. That's correct, because speed is a scalar quantity, whereas velocity is a vector quantity. It has both direction and magnitude. Question 3. The speed time graph shows the motion of a tennis ball when it's thrown vertically upwards from ground level. What is the maximum height reached by the tennis ball? So as we know, the area under a speed time graph will give you the distance. You just use half base times height. Half times 2 times 20 should give you 20 meters. Next. Question 4. An aeroplane accelerates forwards at a constant height. The diagram shows the direction of forces acting on the aeroplane. Which statement is correct? And so, since it's accelerating forward, we know that's a net force that is going forward. The lift and the weight, okay, should be equals to each other. Okay. Since the F net is non-zero, F net should be equals to the thrust minus the air resistance, and should be more than 0. That's why acceleration is more than 0. So option D. The lift is balanced by the weight. Question 5. A rock is isolated in space very far away from any stars or planet. Means it's not in any of the stars or planets' gravitational field. So isolated in space, we can assume that G equals to 0 Newton per kg. Which statement about the rock is correct? The rock has mass but does not have weight, because the formula W equals to mg. When G is 0, weight is 0. Question 6. 4 solid blocks shown have equal mass. Which block made of the material with the greatest density? So as we know the formula, mvp, P is equals to mass over volume. Since mass is the same throughout, because the question gives equal mass, to get the greatest density, you need to have the smallest volume. So the option is B. Question 7 not tested. Question 8. A ballet dancer balances on one toe of one shoe. She has mass M. The area of the shoe in contact with the ground is S, which is capital A. The gravitational field strength is G, small g. What is the expression is equals to the pressure she exerts, small p question mark, on the ground. Okay, so there's two formulas that we need to use. The first formula is P equals to F over A. And second formula equals W equals to mg. As we know, the force here is actually the weight of the ballet dancer. So P equals to F over A will be equals to mg over A. So since we know that A is capital S here, we get mg over S. Question 9. A truck moving at 10 meters per second along a straight road a car with kinetic energy equal to that of the truck is moving along the same road. So first of all, you can have V for the truck. The mass of the truck is 5,000 kg and is 4 times the mass of the car. What is the speed of the car? V question mark. So since they have the same kinetic energy, you can have Ke of car equals to Ke of truck. The formula for Ke is half mv square. So as we know, the half mass is 5,000 for the truck. Velocity is 10 meter per second square. And since the car is 4 times less, the mass of the car is 4 times smaller than the truck, so we put m over 4. And we can calculate that V is equals to 20 meter per second. Question 10. A box slides down a slope. A force of friction 12 Newton acts on the block as shown. So 12 Newtons, this direction. How much work done, W question mark, against the force of friction as the box moves from P to Q. So we know the formula, W equals to F times S. Work done equals to force times the displacement in the direction of the force. So in this case, it's moving from P to Q, and this is S. This is F. So F is 12 Newtons. S is 5.0 meters. You get 60 joules of energy used. Question 11. Which statement explains why a liquid has fixed volume but changeable shape? So the molecules are close together. That is for liquid, and they can move over each other. That's also for liquid. So this one move together, close together, but they can vibrate about their fixed position. This is actually for solids. Molecules are far apart, gas, can move away from each other. It's both liquid and gas. Vibrate about fixed position, also wrong. That's for solids. Question 12. The diagram shows a liquid being heated. What happens to the liquid at the bottom of the beaker? So, what will happen is that it will form a convection current. It looks like this. And why does this happen? It's because when the liquid at the bottom is heated, the liquid expands. Okay, it expands, it becomes less dense, and it rises here. But for those liquids that is here, it's actually the cooler liquid is more dense, it sinks. And together, this forms a convection current. So density of the liquid decreases because it becomes less dense, it moves upwards. Question 13. Water can change state by evaporating or boiling. Which rule is correct? Okay, so boiling occurs only at one temperature. In fact, it's at a fixed temperature. Okay, at the boiling point only. Whereas evaporation occurs at the water surface. And also evaporation can occur at any temperature above the melting point. Question 14. The diagram shows a wave on the surface of the water in a ripple tank. The wooden rod is generating the wave, completes 20 vibrations in 10 seconds. So, one vibration is actually up and a down motion. That's one vibration. So what is the speed V question mark of the water wave? If you can see here in this 6 cm, okay, it actually completes 5 wavelengths. One crest, 2 crests, 3, 4, 5. So actually it's 5 wavelengths. So 1 lambda is actually equals to 6.0 divided by 5, which will give you 1.2 cm. Okay, take note of the units. 1 period is actually equals to 20 vibrations divided by 10. Because 20 vibrations in 10 seconds, it will give you 0.5 seconds for the period. As we know, frequency equals to 1 over period. So 1 divided by 0.5 will give you 2.0 hertz. So now you got wavelength, you got frequency, you can use the formula. V equals to F lambda. F is 2.0. Lambda is 1.2. You get 2.4 cm per second for the speed of the water wave. Question 15. What is equals to the period of the water wave? So option A, the distance between two adjacent wave peaks actually gives you the lambda. The time for the surface, water surface at one place to move from its maximum to its minimum depth. Okay, so then I'm also not sure what is it. The number of waves passing a point in 1 second. Actually, that is the frequency. However, the time taken for one peak of a wave to move a distance equals to 1 wavelength is actually the period, which is what we're trying to find here. How it look like on a graph, on a displacement time graph. So you have a displacement versus time. Okay. So between two peaks, the time taken between two peaks is this, is the period. Question 16. A sound generator makes a musical note of a single frequency which a person can hear. Which changes made to the sound generator give a quieter sound and a higher pitch? So we know loudness is proportional to amplitude. Okay, then frequency or pitch is proportional to frequency. So if I want a quieter sound, I want a lower amplitude, I want a higher pitch, I want a higher frequency. So decrease in amplitude, increase in frequency. Okay, question 17. Two resistors in series are connected to a 12 volts supply, here 12 volt, and draws a current of 0.6 ampere. Okay, so this is the EMF, this is the I current. A third resistor is connected to the circuit at the point shown. What is the effect of connecting the third resistor to the circuit? Okay, so first of all, we can put this as EMF equals to 12 volts. You can call this resistor 1 and this combination as resistor 2. Okay, the first thing, RT is actually equals to total resistor equals to R1 plus R2. Okay. If you add more resistors in parallel to R2, okay, what will happen is that you will reduce the resistance of R2 as a whole when you add more resistors in parallel. So if the resistance of R2 goes down, resistance of RT, which is total resistance, decreases. So first part, total resistance decreases, RT. Okay, next. Using the formula, Ohm's law, R equals to V over I, we can rewrite I is equals to V over R. And in this case, your V is your EMF of 12 volts, which is fixed. And your R is your RT, the total current, total effective resistance in the circuit. So since RT decreases, your current will increase. So current increases. However, you will know that your supply EMF is always constant. So it remains unchanged. So the answer is A. Question 18. The three resistors in the circuit shown are identical. The resistance of each resistor is 20 ohms. The reading on the ammeter is here 200 milliampere. What is the reading of the voltmeter? Okay, so since they are of the same resistance of each resistor in both branches, the current should be equal. Okay, so for the top resistor and the bottom resistor, it should both have a current of 200 milliampere, which means when you connect back here, it should have I is actually equals to 200 plus 200, which is equals to 400 milliampere of current going through this resistor. And since we know the resistance is 20 ohms, we can use the Ohm's law. R equals to V over I. 20 equals to V over 400 milliampere times 10 to the power minus 3. You get V is equals to 8.0 volts. Okay, question 19. 80,000 watt electric heater P is used in a factory for 30 minutes each day. The electricity cost, unit cost, 24 cents per kilowatt hour. What is the cost, question mark, of using the heater each day? So I mentioned for cost, we need power to be in kilowatt, okay, and time to be in hours. Okay, so let's use the first formula. Cost is equals to energy time unit cost. Okay, and energy is equals to PT. So times unit cost. So let's sub in the values. P, 80,000, we need to change to kilowatt, which will be equals to 80 kilowatt times time, which is 30 minutes divided by 60 minutes to get it in hours, times the unit cost of 24 cents. You get the answer 960 cents. Question 20. An electric kettle has a metal case. The live and neutral wires in the plug locators are connected correctly, but the earth wire is not connected to anything. There are no other electrical faults. What happens when the kettle is switched on? So in this case, the kettle should heat up normally. However, it will not become live if there is no other faults developing. Okay. And it will just work as per normal, but it will not have the earthing, because the earth wire is not connected to the metal case.